Graph and describe quadratics. We have a bunch of concepts that we want you to understand about quadratics. The first one is that quadratic functions generally have this form. It's ax squared plus bx plus c. And a, b, and c are just some numbers. And a can't be 0 or you won't have an x squared term, so that's where that comes in. But it could be something like this. F of x equals, and my a might be a 2, and my b might be a 1, and so it would be just plus x, and then maybe my c is a 3. So it would look something like that, where I have an x squared term at a minimum, and then I might also have an x term and a constant. When I graph a function that looks like this, it's going to be sort of in a U shape. It kind of looks like that. And we call that a parabola. And parabolas are symmetric, so that means that if I draw a parabola, I will have a line of symmetry that goes right down the middle. Pretend that's a straight line with me. And they're symmetric to this line called, this is the axis of symmetry, the line that divides the parabola exactly into two matching pieces. They're mirror images, so if you fold one over onto the other, it'll match exactly. This is supposed to be a is greater than 0, and if a is less than 0. If we are talking about the minimum on a quadratic, that would be if our a was greater than 0, then the vertex is the point that has the minimum y value. And when we're talking minimum, we're just talking about the y part, or the f of x part of your ordered pair. So for example, if I have f of x equals 3x squared, then I know that my parabola opens upward because my a, which is 3, and 3 is greater than 0. So I know I'm going to have a parabola of this form, and that point where I have the vertex, that is going to be my minimum. So if my vertex were 3, 4, for example, my minimum would be just the y part, or the f of x part, and that would be a 4 for the minimum for this example. If my a is less than 0, and here's an example where that happens, if I have f of x equals negative x squared, then my a is a negative 1, which is less than 0, and that implies that my parabola opens downward, and I'm going to have a maximum, and again I'll use the y value of my ordered pair for the vertex to find what that maximum is. And so when I look at that, this one would actually have a vertex of 0, 0. So my maximum for the parabola in question here would be a 0, because it's opening down. 0 is the highest point on the y-axis for that value. The x-intercepts are going to be ordered pairs like always, but it's the places where the graph actually intersects with the x-axis. So if I have this, try to make a straight line. If I have my x-axis, there's a pretty good one, and my parabola right here, there's an x-intercept and there's an x-intercept. And so there I am showing them. I write them as ordered pairs as always. When I go from left to right on this graph, so when I'm headed in this direction, you can see that it's going down. And then when it hits the y-axis, then it starts to go up again. So this one is decreasing and then increasing. And for intervals. So for this interval to the left of the y-axis, we would say decreasing. And then for this interval to the right, this part would be increasing. So, and it's just talking about how far is it that you see that your graph is headed in a downward direction, and then how far is it that it's heading in an upward direction. So we could write that formally and say negative infinity to 0. Oh, and right at the vertex, it's neither increasing nor decreasing, so I'll need to change that to a parenthesis to indicate. And then wait, it was increasing. Start over. So if I want to be formal and say where the interval where my graph is increasing, that's this part to the right, and right at the vertex it's neither increasing nor decreasing, but just after it begins to increase. And so from there it would be 0 with a not inclusive 0, and then to infinity parenthesis. And the decreasing interval was this part to the left. As I read left to right, my graph is going down, and so that would be from negative infinity to 0, again non-inclusive for the 0. Okay, and that's the idea of increasing and decreasing. Just two more. Domain and range we've talked about already, and with regard to linear functions, but here we're talking about a quadratic function, so we want to address it one more time. The domain of a function describes all the possible x values on the graph. So if I'm looking at a graph, I'm trying to decide what x values could I use to plug into this function. And the function is going to have a form something like this, one of those two. And so I know that I can plug any value in for x, and I would be able to eventually track up to a point where I hit something that was on my graph. So the domain for this function that I drew to the right is going to be negative infinity to positive infinity. And the range, remember that describes all the y values that are possible for my graph. And so as I look from the lowest possible down at negative infinity, I see my graph's not down there, and it's never going to come down here. The first place that I see it is here, and we could call that maybe negative 3. So we can see that we start at negative 3. And then as I increase up the y-axis, I can see that anywhere along here, I'll have possible y values that will be on my graph. So all the way up to a positive infinity. So quadratics are used to solve and to model real-life problems. That's basically what we use them for, and we use them very frequently. Here's an example of a quadratic. F of x equals x squared minus 9. And what we want to do is fill in the f of x table. Remember that x is the inputs, and the f of x is the outputs from our function. So if we have an input of negative 3, that means we are doing f of negative 3, or evaluating f of negative 3, plugging in a negative 3 and put it in parentheses everywhere that we're seeing x. So the first thing I want to do is put whatever the x is squared minus 9, and then I want to plug in where that x was. I want to plug in that negative 3. And I did it in a different color so you can kind of see how the whole negative 3 is what's being squared. And so when you expand that, remember it's negative 3 times negative 3, and that's negative 3 squared. And then when I multiply those, negative times negative, I get a positive 9. So for this one, my next step is going to give me 9 minus 9, and that tells me 0. So f of negative 3 equals 0. That's one way I can write that out. And the other way is to say I have an ordered pair, negative 3, comma 0. Because negative 3 was my x part and 0 is my f of x part. Let's try another one. So I have f of negative 1. That means I'm plugging in a negative 1 instead of my x. So here where I had an x, it's now a negative 1. And then I need to calculate like I did on the last one. Negative 1 times itself, or negative 1 squared, is going to give me a positive 1 minus 9, so I'm going to have a negative 8. So that means f of negative 1 equals negative 8, and that means negative 1 for my x part, negative 8 for my y part. Two ways of showing that solution. Then I'm going to use 0. Same thing, f of 0. Wherever I had my x, I'm going to plug in the 0. This is not nearly as complicated when there's not a negative, so we'll look at that one pretty briefly. 0 squared is just 0, and then minus 9, so I'm going to have negative 9. So I can say that f of 0 equals negative 9. That's also corresponds to an ordered pair, 0, negative 9. Plug in the 1, it'll look very similar. 1 squared minus 9, 1 squared is just 1, and so I'm going to have negative 8. Now we saw that before for the negative 1, we're getting the same answer for the positive 1. See if you can see why that is. So we could report that as f of 1 equals negative 8, or 1 comma negative 8. Then we'll try 3. So f of 3 equals 3 squared minus 9. That's 9 minus 9, or 0. So f of 3 equals 0, or I could report it as 3 comma 0. So I've got ordered pairs, I've got function notation, and I've got all my work showing there, but I do know that I have for these inputs, I have these outputs, and you can see them kind of here. Now I want to take those points that we just came up with, and I wrote them as ordered pairs, so it should be pretty easy for us to take them, but we want to put them on the graph now. So you can see the ordered pairs over here, and we just want to graph those. So negative 3, 0, and 3, 0. I'm going to do those two at the same time because I can remember them that long to get to this page. So negative 3, 0, 1, 2, 3, that puts me right here, and then positive 3, 0, 1, 2, 3, that puts me right here. Okay, then let's see, I have negative 1, negative 8, and 1, negative 8. So let's see where those put me. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8. There's negative 1, negative 8. And then if I go over to 1, it's also at negative 8. And remember that third point was 0, negative 9. Let's just verify real quick that we got them all. Negative 3, 0, negative 1, negative 8, 0, negative 9. There's the one I remembered. 1, negative 8, and 3, comma 0. Now you might be able to tell that I have an axis of symmetry and that this is indeed a parabola and it's opening upward. Not the straightest parabola ever. But there is a parabola there. It's difficult to draw with this device, but there's my parabola. All right, now let's analyze our graph that we made based on the criteria that we were talking about at the beginning of this lesson. So the characteristics of this graph, x squared minus 9. The x-intercepts, remember that's where it crosses the x-axis, and I can see that there's one point right there, and there's the other point right there. So there are two x-intercepts for this graph, and they are ordered pairs, of course, and I have negative 3, comma 0, and positive 3, comma 0. Remember, x-intercepts always have a value for the x part and a 0 for the y part. Now I want to know the y-intercept. So where is my graph crossing the y-axis? So that's this axis in the middle, and I can see right there I do have a crossing. So I'm going to write that in, and that was 0, -9. And remember, our y-intercepts always have 0 for the x part and a value for the y part. The vertex is, in this case, it's the minimum or the smallest point in the y direction, and it is the same thing as our y-intercept. So in this case, it's not always that way, but 0, -9 is also our vertex. Our axis of symmetry, the place where you can take your graph and fold it exactly in the middle, is going to be the y-axis, and the equation for that is a vertical line, so the x parts are going to be the same every time, which is x equals 0. So the axis of symmetry will be x equals 0. Now, if you don't know what the equation is for a vertical line, there's an easy way for you to tell. You can graph that vertical line and just pick 2 points on it, and it doesn't matter how far over it is or whatever. We'll say that one's over 3. So this point here is going to be positive 3, 0, and this point right here is going to be positive 3, say 2. And we can look and see that both times our x part has not changed. So the equation for this line has to be x equals 3. And the same for this line here, where we're looking at the y-axis and trying to figure out what the equation for it is. We can just pick two points on that. Look what's the same, and then say it's either the x part that's not changing or the y part, and that tells you what your equation should look like. Find the maximum or the minimum, and when I look at this graph, I can see that I have a minimum, and I've marked it here in blue, and that means that everything it's a graph that's opening up. I can also look at my function and see here that I have an a of 1, which is greater than 0, so I will have a minimum. And remember, it's at the vertex. My vertex, we decided, was 0, -9, and so the y part of that vertex, or -9, is the minimum. Okay, let's come down to the chart and we'll fill that in on the chart. So I do have a minimum because a is greater than 0, and then that means that my minimum is -9. And then we want to know for what interval is our graph increasing first. So we're looking at where, as we look from left to right, where is our graph going up? And if I start looking, I'm over here, it's decreasing because as I go from left to right, it's going down. And then at the vertex, it changes, and now it's going up. So the increasing part is from 0 over to positive infinity. I'll change my pen color there. So the increasing interval, it's like the domain, but just the part where the graph's increasing, 0 to positive infinity. And remember, we're using a parenthesis because at the vertex, right where it is changing from decreasing to increasing, it's neither one. Okay, then the decreasing interval, that's going to be the left-hand side, because as I look left to right, we're going down. So that's the decreasing interval, and that is from negative infinity. You always put the smallest one first, negative infinity to 0. And remember, we need a parenthesis for the 0. Don't forget, your infinities always have parentheses on them. Now we want the domain. So domain is sort of like the increasing decreasing interval. So we're looking as we go from left to right. We're looking, are there always going to be values that I can plug in for my x? and I can look back at my table, and we chose some values for x, but could I have chosen others like -500, 2 million, any values I want? And the answer is yes, I could. I would just stick them in right here for x, square them, subtract 9, and then I would have a y, or an f of x. So that means that any numbers are going to work for my domain, so it's going to be -infinity to +infinity. Now let's take a look at the range. Range is as I'm going, and I'll show you with this, as I'm going from the smallest values on the y-axis sliding up all the way up to the top on the y-axis, what values am I going to see? Or if I'm looking at my xy table, or my f of x table, then I'm looking at the outputs. And what values can I have for my outputs? So come back here. I can see from my graph that if I'm way down here at -infinity, maybe -500 you could think about, I'm not going to be able to go left or right and actually hit a point on my graph. That won't happen until I'm right here at -9. So when I'm at -9, then there's a point on my graph, and then at -8 I can go to the right or to the left and hit a point on my graph. -7, same thing, to the left or to the right. -6, and that's going to happen all the way up from here because these lines continue on in both directions. And right here, anywhere up to the top, I'm going to be able to find a point on that parabola because it just goes up and up and up and up in both directions. Okay, so but I'm not anywhere below -9. So from -9 up. So that's what I want to represent on my range. And change to my pen again. So -9 all the way to +infinity. And then I left off the symbol on the -9 because I wanted to talk about that. There is an exact point here that we plotted that was 0, -9. And so I'm looking at that and saying, oh yeah, so that 9, the -9 is actually on my graph, so it should be an inclusive symbol for the -9, which means I need to have the square bracket for it.